So now I wanted to look at a few more examples of writing a polynomial if you're given, or writing a polynomial as a product of linear factors if you're given one of its zeros. All right, so let's look at this one. Here we have f of x is equal to x to the third minus 6x squared plus 7x plus 2. And we're given that 2 is a 0, and we want to try and factor this polynomial. So we want to write it as a product of linear factors. Okay, so if we're given that 2 is a 0, that means that we can write f of x, we can write it as x minus 2 times some polynomial, some other polynomial q of x. Okay, so if we want to find q of x, what we can do is we can divide both sides of this equation by x minus 2. So when we've done this rule before, this is really what we're doing. This is kind of the theoretical idea of what we're doing. So what this gives us is q of x is equal to f of x divided by x minus 2. So now we can divide our whole polynomial x to the third minus 6x squared plus 7x plus 2 divided by x minus 2. And for that, we can use synthetic division. Okay? So let's go ahead and take all of the coefficients here. So we have 1, -6, 7, and 2. So remember, we're going to go ahead and bring down this 1, and we'll multiply the 1 by our 0 here, which is 2. Okay, so 1 times 2 is 2. -6 plus 2 is -4. We take -4 times 2 and get -8. So 7 plus -8 is -1. And then -1 times 2 is -2. 2 plus -2 is 0. So we have a remainder of 0, and therefore we can now write f of x as x minus 2 times x squared minus 4x minus 1. And here we got all of the coefficients from the quotient here from this synthetic division. Okay, so all of our coefficients come from our synthetic division here. All right, so now if we want to factor this further, which we do, we can see if we can factor x squared minus 4x minus 1. And we can do that using the quadratic formula. So let's do that now. And remember, we're doing this quadratic formula on x squared minus 4x minus 1. So we have x is equal to negative -4 plus or minus the square root of -4 squared minus 4 times a is 1 times c is -1. And this is all going to be over 2a or just 2 because our leading coefficient here is 1. All right, so we'll have 4 plus or minus the square root of 16, and this will end up just being plus 4 because we have minus and -4. This is all over 2. So we have 4 plus or minus the square root of 20 divided by 2, which is equal to 4 plus or minus the square root of 4 times the square root of 5, all divided by 2. Or we have 4 plus or minus 2 times the square root of 5 over 2. We can pull a 2 out. We can pull a 2 out, and we'll get 2 plus the square root of 5 over 2. So these cancel. So we really just end up with 2 plus or minus the square root of 5. So those are our two other zeros here for this polynomial. And since the polynomial was a degree 3 polynomial, that means that we have at most 3 separate zeros for this polynomial. So we can then write f of x as x minus 2 times x minus 2 plus the square root of 5 times x minus 2 minus the square root of 5. All right, so there is our answer for how we would write that out. Okay, so here we have another one. We have f of x is equal to x to the fourth plus 6x to the third minus 5x squared minus 54x minus 36. And we have that negative 3 and 3 are zeros. Okay, so what this means is we have a couple of ways we can approach this, okay? And I'm going to choose to go one direction, but I'll give a brief explanation of the other direction here. So we have f of x can be written as x plus 3 times x minus 3 times some polynomial q of x that we don't currently know yet, okay? Now, we can go ahead and divide both sides by x plus 3 times x minus 3. Okay, cancel all of this, and then we get q of x is equal to f of x divided by x plus 3 times x minus 3. Okay, so what we can do, what we can do, this is a possibility, is we can go ahead and FOIL x plus 3 times x minus 3. That'll give us x squared minus 9. And then we can divide f of x by x, f of x being this whole polynomial here, divided by x squared minus 9, and we can use polynomial long division. Or what we can do is we can break this into two separate pieces. Another way that we can do this is we can also write f of x. We can break this into two parts because I tend to find that synthetic division is usually a lot easier, a lot more straightforward. We can also break this into maybe x minus 3, okay, times p of x, where p of x is some unknown polynomial that will have a 0 of negative 3 as well, okay? So we can use that other 0 to our advantage here in a few minutes, all right? So I'm going to go this route here, okay? This is the route that I'm going to go. Okay, and that's just because I prefer synthetic division, but you can absolutely use polynomial long division by going ahead and foiling these out and then dividing f of x by the result of this multiplication here. That's fine. You can absolutely do that. Again, I just prefer synthetic division. A lot of times with these types of problems, there's several ways to get to the result you're looking for. So yeah, let's go ahead and do that. So here we have our R value is going to be 3. Our 0 is 3. So we can set up our synthetic division. All right. So we have, for our coefficients, we have, let's put our 3 out here first. We have 1, 6, negative 5, negative 54, and negative 36. Okay. Let's go ahead and bring down this 1. So we have 3 times 1 is 3. 6 plus 3 is 9. All right. 9 times 3 is 27. Okay, so we have 27 plus a negative 5. That will give us 22. 22 times 3 is going to give us 66. 66 plus negative 54 is going to give us 12. So then we have 12 times 3, and that gives us 36. Negative 36 plus 36 gives us 0. So there we go. So now we have that our polynomial p of x is equal to x to the third plus 9x squared plus 22x plus 12. And again, we get all these coefficients here from our synthetic division. So we can write f of x as x minus 3 times x to the third plus 9x squared plus 22x plus 12. Now we also know that -3 is a 0 as well. Okay, so the nice part about that is since we already used the 0 3, we can now use the 0 -3 to go ahead and factor this one. All right, so we can factor this polynomial p of x, or we can at least write it as another product um, uh, by using the other 0. So we can write p of x. We can write p of x can be written as x plus 3 times some polynomial, maybe we'll say capital F of x, okay? And if we want to find capital F of x, we can divide both sides by x plus 3. Sorry, I wrote this kind of strangely. Okay, we can divide both sides by x plus 3. These will cancel. And therefore, f of x can be written as p of x divided by x plus 3. Or we can use synthetic division to go ahead and divide that. So let's find f of x. So we can put our -3 out front here. And now we can put our coefficients of our polynomial p of x, which is x to the third plus 9x squared plus 22x plus 12 over here. So we'll have 1, 9, 22, and 12. We'll bring this one down. So we have -3 times 1 is -3. 9 plus -3 is 6. And 6 times -3 is going to be -18. 22 plus a -18 gives us 4. 4 times -3 is -12. And we add that to 12 and we get 0. So that means that f of x is going to be equal to x squared plus 6x plus 4. So p of x can be written as x plus 3 times x squared plus 6x plus 4. Okay, and therefore we can write f, our initial function, little f of x, as x plus 3 times x minus 3 times x squared plus 6x plus 4. Okay, a lot of steps here, but we're getting there. All right. Okay, so now hopefully we can factor this polynomial quite easily, and it looks like probably synthetic division is going to be our best bet here. Okay, not synthetic division. Sorry, the quadratic formula is going to be our best bet here. So we can we're doing this for the quadratic formula is only for this polynomial, for this x squared plus 6x plus 4. So we have x is equal to negative b, or -6 plus or minus the square root of b squared, which is going to be, we'll just say 6 squared, minus 4 times a, which is 1, times c, which is 4, all over 2a. And that's just 2 times 1. Okay, so here we get -6 plus or minus the square root of 36 minus 16, all over 2. 36 minus 16 is going to be 20. So we'll have -6 plus or minus the square root of 20 over 2. Okay, so we have -6 plus or minus the square root of, and we ended up saying last time this just ended, we've already done the square root of 20, so we can do this from our previous example, which we said it was 2 times the square root of 5. Okay, so again, that comes from breaking the square root of 20 into square root of 4 times the square root of 5, and the square root of 4 is 2. So we get negative 6 plus or minus 2 times the square root of 5 all over 2. And so now we can just pull a 2 out here, and we get negative 3 plus or minus the square root of 5 over 2. And so we end up with negative 3 plus or minus the square root of 5. So we can now write our initial function f of x as x plus 3 times x minus 3 times x minus negative 3 plus the square root of 5 times x minus negative 3 minus the square root of 5. So there we go. That is how we could factor these. Sometimes you'll get complex numbers as well. Sometimes, yeah, there's lots of possibilities when you're doing this for your homework. But hopefully, this is a little bit more help with writing these polynomials of higher degree as a product of linear factors.